Hello. You asked about bar magnets, right? Bar magnets and how their motion could induce a current in a circuit. So again, I have my little circuit. It's really fancy, right? And I have my super fancy bar magnet, right? Okay, when I'm looking at it, the picture's all mirror image, but hopefully it's fine. This is the south side. This is the north side, right? And remember which direction the magnetic field flows, right? It always flows in a complete loop, right? It goes out the north side, around, and through the magnet back to the north side. It's always a complete loop going from the north around to the south. From the north around, maybe around really big, maybe down here, from the north to the south, maybe way out there, and then way back here from the north to the south, right? If you look, right, they're flowing from the north around to the south, right? North to south. That's very important to remember here, right? It's vital. And so I have my magnet, and it's shooting out a bunch of magnetic field out the north end, and it's pulling in a bunch of magnetic field from the south end, right? And I have my loop right here, and I cram my magnet in my loop, right? Should be simple as that. It will induce a current, right? Because the farther I am away from my magnet, the weaker my magnetic field. So as my magnet gets closer and closer, I have more and more magnetic field going into my loop, right? Remember, again, when we're inducing a current, we don't care what the field is. What we care about is how much it's changing. And so if I hold this really steady and don't ever move it, there won't be any induced current, none at all. But if this moves farther away or closer, we have a change in magnetic field. So let's first look at moving it closer. If I take my north side of my magnet and move it closer, right? I move it closer. What I have is an increase in the amount of magnetic field going into my loop. That is increasing. It's getting bigger because as it gets closer, more and more is being crammed in there, right? And so if I have an increase in my magnetic field going into my loop, the induced current is going to fight that change. It's going to fight it. If there's more and more going in, it's going to push back this other way. It's going to push back against that. And it's going to induce a magnetic field going in the opposite direction, right? And so I stick my thumb in that direction. And now, if I'm looking at it from this side, it curls around in a counterclockwise manner, right? But if I look at it from this side, well, that's curling around in a clockwise manner. So perspective's kind of important, right? But either way, it'll curls the same way in my circuit, round and round and round and round. That is when I'm moving the north side closer. When I pull it away, right? When I pull the north side away, well, there's still a magnetic field going in my loop, but now it's getting smaller and smaller. And again, the loop fights that change by inducing a current. And this time, it's going to increase this way because it doesn't want less, it wants the same. And so it's going to make a current such that it creates a magnetic field that points this way. Well, instead of pointing with my pointer finger, let's point with my thumb, right? I point with my thumb in the direction, and again, now it curls around clockwise, the opposite direction. And that makes sense, right? So if my magnet gets closer, there's an increase in field, and it creates a magnetic field. It induces a current that creates a magnetic field that points back the other way, right? If I move it away, that's less and less field going in, so it induces a current to make more field go in. And the exact opposite happens when I turn this around, right? Now, I have my magnetic field is coming in this way, right? It's coming toward my magnet. And so as I move this closer, when it was the north side and I moved this closer, it induced this way, right? Because it fought against it. Now, with the south side, moving it closer, I'm getting more and more field going this way, right? And so it fights that by inducing a current such that the field goes this way. And again, curl your fingers to know which direction the current flows in. When I move the south side away, I'm having less and less go this way. So it's going to make more go this way. And again, curl your fingers in the direction of the induced current, right? And so I can move the south side in and out. I can move the north side in and out, right? And I can do it from this side as well. That's perfectly fine, right? No big deal, right? And again, it's all about looking at the change in the magnetic field, the flux, right? The field that goes through your little loop, right? How much field goes through your loop is the flux. We're looking for the change in that